Okay, everyone. So first of all, nice to meet you all. I am Noah from the marketing team here at SQream. With me are Loïc and Chaim, which will be our speakers for this webinar, and Ohad, which will be our moderator. He's also from SQream. And welcome to our webinar, Understanding and Reducing Carbon Footprint. Just before we start, know that you can ask questions and we will gather them together and refer to them in the end. Just make sure that when you ask questions and write them down, write who you will be referring to and we will read it out loud. And please add your name if you didn't already. And that's it. In a moment, we will start. I will share with Ohad the platform. Ohad, you are welcome to start.
Great. You can see my screen.
Perfect.
Great. Okay. So hello, everyone. Very nice to meet you. My name is Ohad. I've been in SQream for over almost a year after a very long service in the Israeli military. And in SQream, I got a great chance of doing, or I can say, doing two passions at the same time that I really like. One of them is big data analytics, which is what SQream specializes in, which is pretty, if I'm working in SQream, of course, I'm going to be dealing with that. But another great passion that I have is the environment or our planet. And by getting into this webinar and hosting it, I think it's the best thing that could happen to me within this company. So having a great opportunity today of sharing this story with you. But besides me, we've got two more great panelists here with their great stories. And I think all in all, you're going to get and gather three personal stories of data practitioners who got in love with the environment at the same time and actually decided to do something with it, or at least have an opinion, which is a lot of what most of us really have about it. I'm going to start a little bit, then Chaim's going to speak, and Loïc, everyone's going to present himself on his part. So be patient. You're going to hear about all of us, and you're going to have a lot of time for questions and whatever else you want to do. So let's begin. When talking about knowing your analytical footprint, first, we need to understand if there is a problem with big data analytics and the environment, or does it collide? Well, they definitely collide. I'm going to deal a little bit with numbers, and Chaim and Loïc are going to do it much better than I do. But just to get in line with everyone, when talking about numbers, we're mostly talking about the information, the communication and technology sector, which is responsible for growing greenhouse gas emissions. As you can see, it's not going to get better. It's only going to get worse. Hopefully, by the decade of 2030 and 2040, hopefully our technology is going to get better, and the numbers, as you can see on the graph, it's going to get better. I took the numbers from the UN Environment Program that were presented in the COP26 by the end of 2021. But I think the more interest is the pie charts on the right. They're pretty interesting because, as you can see, most of the things that within the ICT sector that was got larger greenhouse gas emissions is data centers. Most of us working in companies or universities know that we have data centers in the company somewhere, or server room somewhere. I don't know how many of us have been there, but as time goes by, more and more of us are working on the cloud. Where data center sits somewhere over there, we don't even know. And most of the time it's outside of our country, and we actually don't know how a data center looks like and what our data center is doing, how many carbon it emits, what's going on out there besides us running a query or us putting up an analytical workload or a data pipeline, but what's going on besides that. So you're going to see a lot of numbers today. Not all researchers and scientists agree on those numbers, but the fact that most of them agreeing upon is that the actual emissions are probably much higher for the ICT sector. So take your percentage and your estimation about the real numbers that you're gonna see today. When we're zooming into the data practitioners' world about this problem, we're seeing where exactly big data analytics and the environment collide. So first of all, big data is exploding. We used to say big, now we can say gigantic, huge, tremendous. I don't know, choose your word or suit your superlative for how big data is getting even bigger. Well, it's gonna get just bigger. It's not gonna get smaller, as all of us understand. And it's gonna get bigger because our compute needs, and specifically the AI or ML models we're using, is getting much bigger, we're getting much smarter, we're getting much more efficient in working with big data because of great softwares and tools that we're developing, such as SQream. But you know, we want to use more and more data because we understand better models at the end. It becomes from more and more data. Most of us are still using CPUs though. We pretty much enjoyed Moore's law that every 2 years CPUs are getting double the efficiency, but Moore's law, this efficiency is being flattened, and Moore's law it's not going to be as good as we know it in the past decade or two. So our CPU efficiency in most of our databases, data warehouse, and most of the hardware that we're using is still CPU and not other hardware. Even though there are a lot of experiments from some companies try to develop something else besides the CPU. Moving on more to the business side of the house. Well, you know, all businesses and organizations want to be data-driven, want their decisions to be based upon data. And as you can see in each and every industry, the category leaders in it are not a better company works more efficiently. They're just working with their data more efficiently. And every company today, you know, most of the companies are really good data companies, and not, I don't know, just take Uber, for example, or Lyft, for example. They're great data companies using data about transportation. They're not data of, you know, cabs or taxis companies. And as for the customer side that we're all working in companies are serving, well, all of our customers are not going to wait for our decisions, or not going to wait for our business insights, and their environment or their experience working with our products, they just don't have the time to wait for it. So we want the best performance for them. They want the fastest experience, the smoothest experience. And if you want better experience, your performance and your data workloads gotta work faster. So we have more data, and you want it to work faster and get faster business insights working with just tons of data. But now when we talk about a data engineer or algorithm developer or just someone working with data in the world, doesn't really understand that those two worlds collide, does he really care? So in SQream, we took a little, in one of Reddit's biggest communities, we took a short poll of was running a week about, you know, do you measure your analytical carbon footprint? I guess most of the people didn't even know what we mean when we say analytical carbon footprint, and hopefully all of you guys will get, you know, more aware or more understandable of what this term means after this webinar today. So, you know, most of the people don't really care. They don't know what it does mean, or, you know, they do know that there's something behind it, but you don't have any grasp of how to do it, or if they should do it. And as you can see, no one is actually measuring or optimizing his data analytical workload on a daily or a monthly or yearly basis. Just don't know what we're talking about. Luckily, when I started getting more interested in this topic, I was Googling around like I'm doing every time I find a new topic interesting. And I found a great article right by Chaim, who is with us today. Luckily, I met him and I got to know him through LinkedIn and his initiative and his ideas and how he got to the idea. But it's not going to be a good idea if I'm going to tell Chaim's story, because we brought him here today for you guys. So I'll let Chaim speak for its own. The stage is yours.
Thank you, Ohad. Okay, just 1 second. All right, I think you guys should see my slide deck now. Okay. So first of all, thank you, Ohad, for the opportunity to talk about this important topic. Hello, everyone. My name is Chaim. I am a computer vision and machine learning algorithm developer. Specifically, I specialize in training machine learning workloads in the cloud. What this means is I take machine learning projects, port them to a cloud environment, and find ways to run them in the most efficient and optimal way possible. Over the past few years, I've started blogging on topics related to this area. I've pasted a link to my blog in the slide so you can have a look. Please feel free to reach out to me with any questions. Over the next few minutes, I would like to talk to you about my own personal perspective on the carbon footprint of deep learning. I'd like to start with an AI application that has received a lot of attention in the press over the past few weeks, DALL-E 2. DALL-E 2, in case you have not heard about it, is a new AI system created by OpenAI that was trained to create realistic images based on provided captions. Taking the bottom right image as an example, if you type in a caption such as "a teddy bear on a skateboard in Times Square," the model will produce this cool looking image, which I should emphasize is computer generated. If you search online for DALL-E 2, you will find all kinds of examples of unusual captions and their associated DALL-E 2 outfits. So while this cool application has received a lot of attention, the carbon emissions involved in its development have received little to no attention. Building applications like DALL-E 2 requires an enormous amount of compute power. They require weeks to months of training on huge amounts of input data and on heavy machinery. The details of training DALL-E 2 are hard to come by, but as a point of reference, we can look back at DALL-E 2's predecessor, DALL-E 1, which was trained on 1,024 GPUs. This might not mean much to you, but if we take these numbers and plug them into this amazing tool that you will hear more about later, we can get a report of the estimated carbon footprint. Just one day of training, a single experiment in a cloud environment is equivalent to roughly half of a 23-hour passenger flight from New York to Melbourne. I'll let these numbers sink in for a minute, and then I will tell you that in practice, the actual carbon footprint of building DALL-E is probably orders of magnitude higher than this, as deep learning engineers will typically run multiple experiments over periods ranging from weeks to months. This finding is not unique to the DALL-E model. A 2019 paper found that common NLP models have an enormous carbon footprint. This is one of the tables from the paper comparing the emissions of common models to familiar consumption. I find these numbers shocking, and this was back in 2019. Since then, models have gotten much, much bigger. On a personal level, reading some of these papers, I am sometimes astonished at the ease at which algorithm developers will just spin up dozens of parallel experiments despite the associated environmental cost. Clearly, we have a problem. Or do we? Over the past few years, major cloud service providers have embarked on extraordinary initiatives to reduce the carbon footprint of their cloud services. This is an announcement by Google about their intentions to decarbonize by 2030. And this is a report from 2020 by AWS claiming that they are on track to reach 100% renewable energy by 2025. Perhaps our discussion today is short-sighted. Perhaps we really have nothing to worry about. As much as I would love to meet back here in just a few years' time, and for us to be able to declare that the problem is solved, I think a healthy amount of skepticism is warranted, especially given what's at stake. For example, if we take a closer look at the report from AWS, we can see that there was actually a 19% increase in carbon emissions in the year preceding the report. The report also states that it may take several years before the investments are reflected in the actual carbon footprint. At the end of the day, these initiatives are outstanding and highly commended, but I do not think that we have the luxury of waiting this out. So what tools do I, as a deep learning engineer, have at my disposal for managing carbon emissions? The first thing we can do is to optimize. That is, make the most of the training resources we are using. You will hear more about optimization shortly from Ohad. The second tool we can use is a carbon footprint calculator that predicts emissions. This allows us to make better decisions about how and where to run our workloads. You will hear more about this from Loïc. Lastly, we have a carbon emissions report, a post-facto report of our actual carbon footprint. This is something many cloud providers have developed over the past few years as a way for customers to measure their cloud carbon emissions. Here's an example of the carbon footprint dashboard in AWS. The total amount of energy used in the case shown here amounts to the equivalent of 1.2 MT/CO2, 75% of which was saved due to the use of cloud services rather than running on one's own machines. But as before, I think this report should be read with a critical eye. For example, The next line item breaks down the savings into savings due to Amazon's investments into renewable energy and savings resulting just from the fact that we are running on AWS. This is a bit of an enigma to me. It is not immediately clear why running on a GPU in the cloud would be more efficient than running on my own GPU. This is something I would like to get more information about. What assumptions are they making about my on-prem environment, and how is the AWS environment so different? Additionally, there are some clear shortcomings to the carbon footprint tool. According to the announcement, there is a delay of up to 3 months until this report is updated. Furthermore, the machine learning developers, the ones actually starting up the heavy machinery, may not have access to this report as it appears alongside the billing report. I tried to access the report in my own company, but did not have sufficient permissions, and there is not a lot I can do with a report that I cannot access. In general, these dashboards are great at telling me post facto how much harm I have caused, but it is not immediately clear how I can use this information to reduce this harm in the first place. A couple of months ago, I published a blog calling on cloud service providers to expose upfront information about the expected carbon footprint of compute instances. This could be in the form of offering compute instances that would be guaranteed to run on clean energy, what I called green instances, or at the very least, a rough estimate of the carbon footprint of different machines that would take into account the availability of clean energy in different regions. To give you an idea of what I am talking about, when you run a machine learning workload in the cloud, you need to decide what type of instance to run on. This is a screen from AWS that allows you to filter and choose instances based on their properties. What I would like is for this screen to include details about the expected carbon emissions of different options. Will the instance run on clean energy? What is the expected footprint of running it? In my mind, this kind of feature has a number of significant advantages. Firstly, it does not take an expert to realize that the psychology of having to choose upfront between a clean and dirty instance is completely different than getting a post facto report. I believe that this feature will increase awareness and make users think twice about the actions they take. Second, such a feature would enable customers who are conscious of their footprint to schedule their workloads according to the availability of clean instances. And lastly, as a byproduct, this feature would increase transparency of the cloud service providers' carbon-free initiatives, as presumably their progress over time would be reflected in the number of green instances available to the customers. I do not underestimate the potential challenges service providers might face in exposing this kind of feature, but I would like to believe that it is doable, and I think that it is our responsibility to demand it. In conclusion, I may have given cloud service providers a bit of a hard time, but they are certainly taking steps in the right direction, and for that, they ought to be commended. But at the same time, I think we need to demand more. And with that, it's back to you, Ohad.
Thank you very much, Chaim. That was awesome. It was great meeting you, but at the same time, getting to know your stories, it's a whole different thing. So very thank you for your honesty in showing us that. Moving on back to my timeline and my story from this. So when I arrived to SQream, I as an analyst, I did a lot of market research and other products and competitors research. And as a part of it, when you work in the data industry, we use a lot of benchmarks. Well, benchmark is like a test you do that would say what's your performance of your platform, how much does it cost, how time does it take you, what everyone is doing, and everyone is fighting against each other who's doing it the fast or the cheapest, and everyone what's best results over there. So about a year ago, SQream got obsessed with that. When start migrating our product into the cloud from the on-prem version to the on-cloud version, and we started just internally checking out what's going on with SQream's performance, how does it perform against other cloud data warehouse giants such as Redshift or BigQuery or Snowflake or Azure Synapse. But after getting results we're satisfied with, we start just putting them in every customer-facing activity that we had, and it looked pretty much like that. Here I give you an example of if we took the 300 terabyte benchmark running 20 queries against this data set by the TPC. It's a council of doing data benchmarks that are acceptable upon all the data vendors or the big data platforms. And we usually talk about, you see on the upper side, you see the ingestion time and the query time and the SQream measurement of what we call the total time to insight. On the bottom side, you see the cost, the compute cost, the storage cost, but just in the cloud, pretty much easy. That's what we used to. But one day was the early 2022 when SQream CEO Ami came to me, who was my direct boss, came to me and asked me, what we're doing besides that. Because SQream is working on GPU, and most of the time we have this measurement that one server running SQream can replace 2 racks of servers. Because SQream is running on GPU and on a CPU, and because its force and the architecture around the CPU is much better and knows to it on a great parallelism and performance. So besides lesser physical space in data centers, what does it mean? And like before I met Chaim, I went to Google again and started to figuring out how can I measure it, if there is any tool I can do, because I wanted to see if we can add it into those benchmarks, another measurement or metrics to see that besides physical space, what's the effect of SQream on the environment. So I firstly got to a great article by 3 researchers from Cambridge University, which is Loïc, who's here with us, and 2 of his colleagues. And I started reading this article, and I haven't been in university for a few years. It was pretty hard for me to read it, but I got into it at the end. And throughout the article, you can find a link to a website that they founded called greenalgorithm.org. It's not on the first place on Google. Maybe you hear Loïc's story and you understand why Google is not putting it that high a rank in its search. But what I like when I got to this website is the customization you can do to a query. Because I wanted to use each benchmark on its own, I really like the fact that I can predict what's going on, and after I did it, I can understand what was my effect on the environment. I can take the runtime on its own, the type of course, whether it's GPU, CPU, the specific model of the course that I'm using, or the hardware that I'm using, the available memory, if it's on-prem, if it's on cloud, where the cloud is located. I can custom it on my own, understand the effects of using different types of hardware, different type of machines, or even different types of locations. For example, if I were using a cloud that sits in US or in Norway, the carbon footprint would be different. And that's what I really liked about this website. But it's just going to be very boring if you're going to hear how I was excited about the website. So let's hear it from Loïc itself, how the website was established and what's the story behind it. Loïc, the stage is yours.
Great, thank you, Ohad, for the introduction. Hopefully it works for everyone. I mean, 2 years into a pandemic and we still can't sort out Zoom, but here we are, a bit early. So hi everyone, I'm really happy to be here today, especially, it's really good to hear about such a different perspective. And as Ohad said, so just a bit about myself, I'm a research associate at the University of Cambridge. And so I'm working primarily, my background is in machine learning and AI, so we probably all do about the same. So I mainly work on how to use that for biology and medicine. And I kind of stumbled across the carbon footprint of computing. So now I spend a fair bit of my time on that. But it's really good to talk to people in industry, because obviously, as we've seen today, it's really not a problem only for academia, but it's very much the same problem for anyone working on big computers. So in the next 20 minutes or so, I'll try to address 3 questions, building heavily on the great talk from Chaim and the great examples from Ohad, which is where does the carbon footprint of high performance computing come from? And how can we estimate it and understand, what impacts it? Then the next part is green computing easy? hopefully by the end of it, you'll be convinced that it can be, not everything, but you can make like significant steps fairly easily. But is green computing easy enough? And that's the part where I'm not really sure about. All right, so let's get started. I mean, I don't need to convince any of you of the impact of high performance computing, but I just thought it was interesting to show that it's not only, obviously AI is a big part of it, but it's not only AI. It also applies to any field. So, well, the biology one is an example of deep learning, but the first one is an example applied to astrophysics, where the first image of a black hole, which was made only possible by the progress in data centers and high performance computing. So that's the plus side. That's why, DALI, what Chaim's mentioned, there are loads of like great examples of what we can do with that. And then there's the flip side. Air pollution, it's 4.2 million deaths per year, and it affects 91% of the world population. And I'm not saying, it's all caused by data centers, not at all, but data centers do contribute to air pollution. That's just a fact. They need electricity to run, and electricity generation is responsible for part of that. So data center, it's hard to quantify the total carbon footprint of data centers in the world, but there is an estimate from 2018, which is about 100 megaton of CO2 equivalent per year, which is the same as the entire commercial aviation industry in the US. And they do love their airplanes over there. So it's a real topic. There is a massive carbon footprint. We just can't be ignoring it. Now, again, not all data centers, it's not all business analytics or all research, but there is a big responsibility of anyone relying on data centers. Now, briefly, how we got to start this project, because my background is not in environmental studies at all. It started in January 2020. So these are pictures from the bushfires in Australia. Quite striking pictures, and obviously this is just a striking reminder of the consequences of climate change. It just happens that part of our lab is based in Melbourne, Australia, so we have we have tight links with them. So that's maybe it just struck a chord a bit more than it would have if we wouldn't have these links. And we also at the same time came across the article by MS Trubel that Chaim's mentioned before about the carbon footprint of language models. And so we just thought, okay, we all do computational biology and bioinformatics, and we also rely on algorithms that run for a long time. It's not only AI. So what's the carbon footprint of what we're doing? And that was very much started as a 2 days, 1 week project. I was like, okay, I'll spend a bit of time, I'll poke around, I'll find a calculator, I'll plug in, details about what I'm doing, and then I'll be able to, that will be like a fun fact I can put in my thesis, or I can put in a paper, and that's going to be fun. And I'm here 2 years later, and it's still going. So because the main problem was, there was no calculator. There was like a few papers, like MS Trubel's and a couple of similar, dedicated to deep learning. So great, but that's very specific. That's only using a certain type of GPUs on the cloud, and that's a very specific use case. And in computational biology, we're using a lot of CPUs. So no tool. So we had to make one, which takes a bit more time, obviously. And that got me thinking, why? Well, first, why was there nothing out there, and why do people not care about it more? I mean, like Ohad's poll was a great example of that. Half people didn't know about it, and well, half people didn't care, and the other half didn't care enough to do something about it. So part is, I think, the environmental impact of computing is it's much more abstract than for a car. You don't see a smoke coming out, you don't smell it. It's usually in a data center halfway across the world. It's not advertised. If you buy a fridge, if you buy a dishwasher, now you have these little like colored letters and stickers, and that tells you, how environmentally friendly your device is. That's not the case for computers. That's not the case for phones. The only time you'll talk about energy efficiency is to tell you that the battery will last longer, but that's about it. So it's not a marketing argument. Computing is free. I guess depending on who is listening now, maybe you're the one footing the bill at the end of the month, and you will strongly disagree with what I'm saying. But in academia, at least, we have institutional data centers, and you have a free allocation, and it's quite a large allocation. And I'm sure for many of you in industry, it's the same thing. Even if it's not free, it's quite cheap, and it's usually not the bottleneck because, understandably so, it shouldn't be a business stop to not have enough compute. So as long as it remains reasonable, I guess it can be considered free, and that's not at the forefront of what we think of. There was nothing to calculate it, so I mentioned that, and institutional friction. So not everyone has interest in us reducing our computing, or at least being more sustainable. Something that may seem unrelated, and usually I end up like removing this slide, and every time I do that, I have a question about it, so it's now a permanent feature of the slide deck. Cryptocurrencies. It's no surprise that they're bad. It just uses a lot of energy. So there's this calculator from the well, actually just around the corner from the University of Cambridge Business School, and they just like estimate in real time the carbon footprint of Bitcoin. For context, this is in the top 30, it's like around 27th if you were to rank all the countries and you were to consider Bitcoin as a country in terms of energy usage, which is just mind-blowing, really. Like everyone in the country is using as much energy as Bitcoin, especially if you put it in relation to the actual benefit to society provided by it. Yeah, and some would say more important metrics to compare it to. Another way to look at it, and well, at the top left you'll recognize the Scribble paper that was mentioned before, is that sustainability is a topic, and some people have raised, like we know the first one from it. It's been mainly around deep learning and artificial intelligence. Something to keep from the Green AI paper and the stochastic paper, Parrot paper, is that sustainability should come with like accessibility and ethics consideration, and that's two like tightly linked problem. One example is if you notice that the populations that will benefit the least from the improvement of Apple's Siri or Amazon's Alexa or DALL-E are also the populations that will suffer the most from any climate change disaster. All right, so do everyone agree that this is a big problem? Not quite. So these are papers from the Google AI team who are not very happy with people poking around and saying that AI is maybe not all pink and all great. So they're basically saying that we should stop looking at it, please, and also if there's no impact, it's all good because no one, the big models are trained. And there's some valid point, and it is true that cloud computing gets a lot better, and it is also true that training a large language model once so that other people can use it is a valid approach. But it doesn't mean that we don't have a problem, because research, computational work is a lot wider than that, and AI work is it's just a fast-growing field. Everyone tries to improve on everyone. There's a lot of duplicated research, and yeah, unsurprisingly, Jan LeCun, who is the head of Facebook AI, agrees with that. That please stop looking at the carbon footprint. It doesn't matter. So, despite what all these people are saying, I think we do have a problem, and what's important to come across is. I'm not saying we shouldn't do it. I mean, I do AI, so I'd be out of a job. But we just have to be mindful of it. It's not because we know that cars are bad for the environment that we don't drive anywhere. It just means that we're mindful about, is it really worth a massive drive to do something that we could do over email? So that's this kind of question. It's just saying, acknowledging that there is an impact. We have to be mindful of it, and we can't afford to ignore it. All right. So how do we do it? How do we estimate the carbon footprint? Well, we can break it down in like three main elements. The first one is what we call life cycle footprint. So it's cradle to grave, which means it includes extracting the raw material, manufacturing the device, using it for its entire life, and then disposing of it. And for any consumer device, so consumer devices, it's your phone, your laptop, your tablet. This is 70 to 80% of their carbon footprint is only from production, which means that any improvement you can make and charge your phone every other day or things like that. I mean, it's great. But you're only acting on the remaining 20%. So not using your device, not getting a new iPhone and just repairing or like keep using the same device for longer is the one single best thing you can do to reduce your technological footprint. This share is a bit lower for data centers, obviously, because they, you know, in a data center, the hardware is used almost continuously. So usage takes a bit more of the carbon footprint, but that doesn't say that we shouldn't use sustainability when deciding about renewing hardware. This is not really the case for now. Mostly it's decided based on cost. Is it cheaper to repair or is it cheaper to replace? But it would be great to include sustainability a bit more. Then we get to storage. Storage is often ignored because a data, hard drive doesn't use that much power, but it uses power for a lot longer, because when you put data somewhere, then you're expecting the data to be available for years. If you look at the energy bill of a data center, you get half of the average one, only half the power will be used to power the computers, 10% for storage, and the remaining 40% will be overheads, which means mainly cooling. And 10% is not a lot, but 10% of a big number is still a big number. So using the same estimator we used at the very start, this is as much electricity as generated by some entire countries. So this is something to be mindful of, and it just means like don't store useless data. As an order of magnitude, you can remember it's about 10 kilograms of CO2 to store 1 terabyte of data for a year. And now we get into the main part of the problem, which is powering the computer during a task. You run a pipeline, you run an analytics, you train a model, you do something. What's the carbon footprint for this like 24 hours where you do it? And that can be quite like difficult to estimate. You don't know what to include. Do you include data centers or the laptop or HPC? You don't really know what to include. You don't really know what hardware to include. And there's the question of energy production. So that's why it was a difficult problem. And I can totally understand that people didn't want to dig into this rabbit hole. So it's actually not that complicated. We can make it a bit simpler. So the idea is, it depends on two things. It depends on how much energy you use. And the energy you need, it depends on two things. It depends on the hardware you use and the task you're doing. And that's it. And then there's how do you produce the energy needed? And that's only depends on how the electricity is generated, which is either the energy source you have, or mostly the energy policy in your country. If your country is massively relying on nuclear, then it's probably quite green. But if your country is relying massively on coal, then it's probably not very green. So if we look at the first aspect, it's a bit barbaric, but let's dive in. It just depends on the running time. Obviously, the faster it runs, the less carbon, the less energy it needs. An example here is, so these are bioinformatic tools, so just ignore the name if it doesn't ring any bell. But if you just look at the first blue, like green, bluish bars, it's the same task, exactly the same task, using two versions of the same tool. The first one, the V1 or the V2.3, so later version of it for genomic analysis. And you can see that updating to the latest tool in this case reduces massively the carbon footprint. No miracle here, it just means they made their algorithm a lot more efficient. That just shows how important it is to update to the latest tool. We all hate updating softwares, because you do that, it breaks your entire pipeline, you have dependencies issue, nothing works anymore. But just keep in mind that it may be worth checking whether it will, even if it's not business critical and even if it doesn't impact your runtime or your business, maybe you will be able, by updating, to reduce your carbon footprint, which is a good thing. Then it's how much power you need for the hardware, and we just focus on two things. We focus on the processing core, so CPU or GPU, and the memory. And finally, how efficient the data center is. So that's like the 40% overhead kind of thing I was mentioning before. And that's where cloud computing is particularly good, because they put a lot of resources into making their data centers as efficient as possible, but they're not the only ones. I know the data center we have in Cambridge is particularly efficient as well. So that's an information good to have. The more efficient the data center, obviously, the less energy you need to do your task. Cool, a quick focus on memory. You would think that the memory, and so did I, it depends on how much memory you have, but also how much memory you use and how often the memory is accessed. Turns out not quite. There was like this study released a few years ago that showed that it almost entirely depends on how much memory is available, and that's it. which is a good news to estimate the power needs because it makes it easier. A bad news if you tend to just, save 200 gigabytes of memory on the cluster just in case. I'm hoping and expecting this kind of result to be about to change or to be changing already, and it probably will be more dependent and more energy efficient in the near future. But for now, that's where we stand. All right, and then we get to the how the energy is produced part, and that depends on your country mainly. It just depends. There's such a big difference between countries. It's a bit mind-blowing. If you do the exact same analytical pipeline in Switzerland compared to Australia, you will emit 74 times more greenhouse gases doing the exact same thing, just because the energy mix in Australia is a lot worse than in Switzerland. So if you want to check out your where you are or where you do your compute, electricity map is a really good resource. It's really interactive. You can see where your country is importing energy from, like the source and everything. It's really great. It's in real time. So yeah, do check out if you want to look at that. And that just shows how important it is if you can choose your computing location. Again, particularly easy if you do cloud computing, but maybe you're able to choose your location in a different way. If you're working in a large company and they have data centers a bit all over the world, picking a data center that's in a green location will make probably the biggest difference you can make. So I've talked a lot about cloud computing, and so have the previous speakers, and for good reason. There's a lot to like. You can choose the location most of the time, so you can pick a green location. They have extremely energy efficient data centers, and all that is really good reason to use it. It's just good to be mindful of a few of potential downsides. So when they advertise efficiency, they advertise the PUE. Depending on who advertises it and the way it is advertised, it may be quite misleading. Sometimes they will be only the best PUE advertised, which means it may be a data center in Iceland, which obviously doesn't need quite a lot of cooling. You just open the windows and you sort it, as opposed to a data center in Texas. So it's not quite clear that the PUE they're advertising is the one of the data center you're actually using. So you may think you're using an efficient data center because you're using a cloud provider, but actually the one you're using is an old data center, is actually not efficient at all. So be mindful of that. And also when it's talked about, your compute is carbon neutral, it often relies on offsetting, which means buying carbon credits, which is something that has very debatable benefits, because it's based on the assumption that the tree you're planting will stay at the same place in the same environment for the next 30 years, which well, it's quite hard to guarantee. So we'll get back to offsetting in a minute, but there's a lot of potential. Just be mindful of the potential downsides. So we just get back to what was mentioned before. We need to estimate and acknowledge our carbon footprint both after the task, but maybe more importantly beforehand to include it in cost benefit analysis. This is no surprise. The more times you run the models, the bigger the carbon footprint. I mean, there's no wizardry here. So yeah, just be a bit reasonable, and running the pipeline for the 100th time on the hope that you will get a slightly different result is maybe not the best thing to do for the environment. So the main problem here was the lack of standardized framework and tool to estimate the carbon footprint of computation. And so yeah, we made one. I'll just show you quickly. That's what the app looks like. Feel free to just jump on and Google it. And yeah, so you just enter the runtime, the type of core. So here we have like CPUs and GPUs, and we can just one more GPU, for example, and you say what you're using. So let's say, yeah, Amazon Web Services, for example. You can pick your location, or for some providers like Google Cloud, we have like the actual list of servers, so it's a bit easier. It's just the information is just not available for Amazon for AWS. And yeah, you just say, okay, let's say we run the analysis 20 times, and it gives you the carbon footprint, the energy need, and the tree, the number of trees, or how long it will, this will take 19 years for a tree to absorb the consumption of your one pipeline. So you need to plant a lot of trees. But again, as we said, offsetting is not great, or equivalence in terms of flying or driving. The main lesson of that, usually people say, oh, but that's actually just half a flight. And the main lesson is actually flying is a lot worse than we think it is. I think that's the main thing you learn when you do that, because yeah, it's not that the compute is not that bad. It's actually flying is a lot worse. And you can share your results, and yeah, you have a breakdown of the data. a bit more information about everything and stuff like that if you don't want to read the paper, which is fine. So feel free to check it out. Hopefully that's helpful. If you find bugs and stuff, people do once in a while. It's all on GitHub. The data is all open access, so you can check out the math, check out that we do it right, check out how we calculate everything. You can replicate everything if you want in Excel or whatever. Feel free to post messages there if you find anything going wrong. Now, we were wondering, is it good? Does it work? Oh, but before does it work, do people want to use it? And we could have been doubtful. I'm glad we didn't have the survey, like the Reddit poll when we started. We probably would have never done it. But it turns out, yes, people do want to do it. It's quite a niche topic, and it's not like we're not going for like millions of users, clearly, because it's only for people, especially because at the start it was mainly directed as like computational research. So it was mostly academic people looking at it. And it's from all over the world. We have like about 200 users a week now, which is quite nice to see that people keep using it on a fairly consistent basis. So yeah, people do care. They just needed the tool. And the next legitimate question was, does it work? And yeah, it does. So it's quite hard to benchmark because you need to have access to the data center and to be able to like measure how much power goes in and out. And I can't do it. I don't have this kind of access. Turns out Google does. And they decided to benchmark our tool very nicely, although it was part of their paper saying, carbon footprint of AI is a lot less bad than everyone keeps telling you. But they tried to show that our estimator was way off. That was the main goal. So that's the green bars on this. And you can see that basically we want the bar to be as close to 1 as possible. That's the goal. And it means it's perfectly accurate. And the one I framed here, they're actually surprisingly close because, we're making assumptions. You have to, because you can't know everything. So you have to make assumptions. So it's actually practical for everyone to use it. And we're really close to 1 in many cases. So I was really impressed by that. I'm really happy with it. It means it works. Then obviously the main comment is to say, oh, but look at these bars up here. It's massively overestimating carbon footprint. And it is. So then we're wondering, well, why is it so off on some and so accurate on others? And then you notice that the ones it's really off on are all the experiments run on Google's own TPU. So these are, for those of you who are not familiar, they're like Google-made GPU-like chips, but dedicated for AI. And they don't sell it. The only way to have access to these very efficient, very fast chips is to run your models on GCP. And for any manufacturer, any publicly sold GPU, the power consumption is available. That's data that's usually called the TDP, and they just release this information. Naturally, because Google don't sell that chip, they don't need to say how much power it needs to be provided with. So we don't really have accurate information. So the main lesson is, when the information about the power consumption of the hardware is available, the estimator is really accurate. And when it's not available, then it's not accurate, which is something I'm happy with because we can't make up values. So transparency is key. That's the main lesson. It's really important to be transparent. But I'll get back to that in a minute. But otherwise, it does work. And most of us work on commercialized GPUs. A few interesting things we learned along the way. More calls is not always better. I know it's tempting to try to parallelize more and more, but a lot of you who do it, know very well that, if you throw twice as many calls at a task, it doesn't mean you'll reduce runtime by 2. You'll probably reduce by like 1.5 if you're lucky. So sometimes, you'll go from like 30 to 60 calls, and you will save, maybe you'll go from like 55 minutes to 50 minutes for your pipeline. Then it's worth asking yourself, okay, I'm saving 5 minutes, which if you don't have any cost to your call, then it's fine. But you will also multiply your carbon footprint by 2. And if you only save 5 minutes, that's not going to offset it. You're probably going to multiply your carbon footprint by like 1.9 or something. So it's something to keep in mind. Is the benefit you're gaining from adding more calls worth the added carbon footprint? And again, sometimes it will be, because you'll make massive times savings, or it will be business critical to go faster. So it's just something to be aware of and put it in a cost-benefit analysis. Switching to GPUs. Well, again, it's very much depends on the situation. It can be a lot better. You know, you've all had this example. You do a pipeline on CPUs, it runs in like a few hours. You do the same on GPUs in like 2 or 3 minutes, it's over. In this case, although GPUs use a lot more energy than CPUs, it doesn't really matter because you go orders of magnitudes faster. And so the carbon footprint will be a lot better with the GPU than the CPU. In some other cases, it's not quite so good because the GPU is not well, you don't make as much gain with the GPU. And when that happens, well, maybe it's worth considering if staying on CPU is not a better option for the environment. I've talked about that before, but memory matters. It's often ignored because we say, oh, GPU use a lot of energy. Yes, but if your pipeline uses a few CPUs, GPUs, but a lot of memory, then memory will probably be the main driver of greenhouse gas emissions. And I've mentioned that before, but the information to make informed decision is often missing. So wherever is your, we all have like kind of a little place in the chain, either involved with like manufacturing or involved with data centers or involved with like analytics. We can all make progress to make sure there is as much transparency as possible. And yeah, offsetting is not a solution and rarely as good as we thought. As I said, it's based on assumptions about the tree staying at the same place for a very long time. So it really can't. It's an easy solution and it's tempting, but it can't be taken. It should come at the very bottom of the list after having done everything you can to reduce it. And then if you really can't do anything else, then you should probably offset many times more. If you need to offset 1 kilogram, maybe you should offset like 10 kilograms because it's not quite clear that what you're doing will have the effect you're expecting it to have. Now, what can we do? Well, I've talked a lot. You've seen all the green bubbles throughout the talk, so I won't list everything again. There's a lot you can do. Hopefully, you're convinced of that by now. And if you want a quick refresher, we published like a very simple. Sorry, Ohad, you didn't come across this one. It's a lot easier to read than the other paper was a bit more technical. This one is very much, it's very short. It's 10 simple rules to make it more sustainable, and it takes over what I said. We worked with that with Alex Bateman from Embody BI in the UK, and so yeah, do check it out if you're interested. And what do we still need? I feel like I'm repeating myself a little bit, but we need to make it easier, and Chaim mentions that before, and that was really important. It needs to be easier for everyone to estimate their carbon footprint, and more transparency. I've talked about that before. So I want to thank everyone, all our collaborators and all the funding body, obviously SQream, for having us today. It's really good to be able to talk about that. If you're interested in the app, I usually publish when there are updates or releases of bugs or stuff. I usually put it on Twitter. There will be actually a release later this week, fingers crossed. I'll just get in touch by email. Really happy to answer any questions or on GitHub as well. Thank you.
Thank you very much, Loïc. That was outstanding. I've got to say, from my personal experience, when I met Loïc and trying to approach him, it was I think one of his most busy weeks. So when we got to him, we ran to hear the story as we get to know him, but I didn't want to ruin the surprise. So probably right now I'm hearing with you guys one of the first times that I'm hearing this story, which is an amazing story. So I'm taking you back to where I stopped my story, which is SQream benchmarks. So yeah, we got to green algorithms. We got all the specs. It was very easy with SQream because we knew what machines we put on the cloud and what specs did they have with the specific hardware. It was not that easy with Snowflake. It was a little bit easier with Amazon Redshift, and we got to this. So we were pretty shocked by the results. We took the same thing, put it on green algorithms, and find out that SQream's competitors are 10 times more carbon emission. They pollute 10 times more carbon than SQream when running like that. But that's just a benchmark. It doesn't, imitate the real world. But we know from SQream's enterprise and big customers that they are running hundreds or hundreds of thousands of queries like that on this size of data sets, and I'm talking 300 terabytes is the average data set that a SQream customer would use. So just imagine that and the difference that the SQream platform and software is doing. And of course, taking it another time from the Analytical website, the difference is about 700 kilometers of driving in a private car. And that's definitely astonished us. And from now on, hopefully using that tool, SQream benchmarks is going to look pretty much differently. Not just talking about cost and performance, but about performance, cost, and the other aspect of cost, which is the environment. Moving on from there, trying a little bit to summarize everything we talked about and give you some practical tools to go on from here for every data practitioner. But let's start now from the personal level, from the more organizational level. You can talk to your IT manager or IT head of department or things like that, whether you're a university or a company, just talk to them and see what they can do. So first of all, move your analytical workloads into the cloud is one of the best and first solutions you can do. We can trust on the big cloud vendors that they have newer hardware, that they have more energy efficient hardware, because they want to also save some money on their electricity bill. So moving our workloads over there, it's the first thing we can do. The second we can do is mostly talking about software. All the software itself that is running the queries or running the data, or is managing our data on the cloud. But we can also use software as an optimization tool if we want, for example, kill machines that are running too much time, kill machines that are working overnight for no reason when no one is in the office, or find any other thing in your clusters that you're running in the cloud, or tenants that you're running in the cloud, that you shut them down if you don't need them, and make them much more accessible and much more efficient. And the third thing you can do is much more depends on choosing the cloud you're using or choosing data center you're using. Just give you a good example of data center sits on water on Norway. When the river is cooling down the data center, no need of AC, no use of electricity at all. But when seeing one of Loïc's charts of what's happening in South Africa, it made me very happy that right now at the moment we have a DataCon conference at South Africa. When we send some of SQream salespersons to sell SQream over there, maybe it can be a good idea of start using a software which is not that polluting at first place. But moving on to summarize all the practical tools that Chaim and Loïc gave us, and I think they did a much better research than I did, but taking it all together that give you what we can do. And specifically, I'm talking here about data workloads, data pipelines that process over 10 terabytes of data, because that's usually just the SQream case. I'm not talking about the 100 gigabyte, things like that, which every kilo of CO2 is important, but I'm talking about the big guns that are actually harming our environment. So the first thing you can do is be aware. You have a lot of tools of doing it de facto, or doing it beforehand. You can predict it, or you can do it on a monthly basis, on a yearly basis, quarterly basis. Just choose your part. You can be on your whole cloud use, could be on a very specific workload, like reading algorithms giving you the option of using, or it can be on your whole data center, depending on everything you do. Just a quick Google search and dug into a little of those tools, but you can use them. Most of them are free. So just start doing it and understand what the cost of the analytical workload that you're running. Second of all, you should prefer choosing to work with transparent cloud vendors. It's not very easy for a lot of us to work on a university or an institution or a company, because they choose for us the cloud vendor that we're using. But besides that, if you can choose, you better do it. I just gave here 3 examples. From the right side, you can see Snowflake, which is, I can say, zero transparency. Not blaming them or anything, but that's that's the website. That's how you forming up a cluster on Snowflake. You have the size, you have the credits, how much you're going to pay, but that's it. How many CPUs? What's the hardware? What's the model? Just don't know. A better example is on the bottom, which is AWS. Chaim gave it also. You get the name of the machine, you get how many CPUs, you get the gigabits that are available for you. But besides that, we just lack the specification and what model they're using of the CPU. Moving on to the last one, which is GCP, when you can run your workloads over there. Then you can choose the specific machine you're running, or for example, it's the best for SQream because we can choose the GPUs that we're working on, the NVIDIA GPUs, which is awesome. I know if there is the best place that I found, but maybe there's some places you got to. But where you can choose, or the first vendor that would adopt Chaim's idea to give you dirty instances or clean instances, that's the one you should choose. Third, it's all about compute efficiency. The faster you go, probably, not all the time, it's not a rule, but probably it will save you save some carbon for the environment, and of course you'll save some money. So cost performance is one measurement, but usually the lower cost performance would give you also a great tool or great solution for the environment. On the other side of it, when using a specific software or specific database or data warehouse or whatever tool you're using, you should prefer choosing GPU. When you should prefer choosing GPU? If you have an analytical workload that demands very fast performance when you want your answers at the moment. If, for example, you're a bank, not very hurry or in a rush to get your business insights, it's going to run overnight. You don't care if you get your answer now, in 5 minutes, or in the morning after. If you're one of those companies, you shouldn't care about how to use and what software you're going to use because you don't really care about performance. But if you want your total time to insight to be as fast as you can or as low as you can, then you must choose, or you better choose GPU. But it just gives you much more work or much more data process per every unit of energy you're using. So if it's a big workload, you should prefer using that. I just put in one of the graphs from one of the researchers I found about the efficiency of the GPU. You can find dozens of them. I'm sure they can refer you to more articles than I've read about it. But if you're not using it, and let's say, for example, you live in a world when you have endless budget and you can just pay more and more and more and more and get better performance by using more racks in your data center or in your cloud, using more and more machines, well, maybe you could get better performance, but it doesn't have to be that you get better results for the environment. Let's, for example, use a huge data center and more racks and CPUs just to get better performance, but the environment is going to pay for that. So it's not always fewer emissions when you have better performance. So that's about it, the 5 practical steps that we formed along. Closing out about an hour of talking just about our ideas and our thinking. And I think the best thing for us to do at the moment is moving on to the questions part. So let me just get it on a platform and see the questions. Okay. So first one is from Bill, who's asking, Loïc, how can I calculate my carbon footprint in green algorithms if I don't know the exact model of CPU or GPU?
That's a good question. You can just use the default value. So what comes as default on the website, I've tried to put like a model of CPU and GPU with like an average consumption. There isn't like that much difference. Well, there's a bit of difference, but it's not like massive. So just use a default value and it will give a ballpark idea anyway.
Okay, thank you for that. I assure you from from a personal point of view, just start using green algorithms. All the answers are over there. So the best thing you can do is just start using it. Let's move to the next one. John is asking, Chaim, can you expand a little bit on how your daily work as an ML algorithm developer, how you're maintaining a low carbon footprint on your daily work?
So I would say that a large percentage of my time is on the optimization part. And this is reflected, I mentioned in the beginning of my talk, these blogs I posted over the past 2 years. The common denominator of all of them is finding ways to optimize your training workloads, making the most of your resources, whether it be doing performance analysis on the GPU, whether it be streamlining your data processing so that you don't have any bottlenecks in the machine learning training cycle, whether it be optimizing the way in which you pull your data from S3. So that is, I would say, 90% of what I do in my day-to-day work. And I have to say, I enjoy it a lot. I find it to be very rewarding. Like you said, Ohad, in the beginning. On the one hand, you know, I'm an engineer, so I enjoy solving problems, and some of these problems are difficult and challenging. And so, you know, I'm able to address these problems, try and solve them, and at the same time, really come away with a feeling that this has an impact, that it does ultimately reduce the carbon footprint. And so it's something I really enjoy. And then on top of that, you know, this hobby that I've developed of actually publishing it and sharing it with the community, I think only adds to the impact of these activities.
Thank you very much for that. And I would like to add a question for that, for what John was asking. Do you find it easy or hard to your fellow, you know, data engineers that sits next to you or in front of you or some of your colleagues of explaining what you're doing, or do you find it practical to lower your carbon footprint as a developer, or you find it, you know, how your fellowships in your company are responding to that?
So fortunately, there is a correlation between reducing when you optimize. So the byproduct of optimization isn't only reducing carbon footprint, but it also typically reduces costs. So fortunately, in that aspect, it's very easy to get people to buy in. You know, if I came to them and said, listen, you know, I have a great idea for how we can reduce carbon footprint, you know, they might not really give me that much attention. But if I come to them and say, hey, I know how to have a great way of reducing our costs, and as a byproduct also reducing our carbon footprint, then it's very easy to get their attention. Money talks. So it's not very difficult.
That's very pleasing to hear.
What is difficult is you know, getting engineers, when they do make decisions about what machines to choose, is getting them to you know, think about, okay, should I choose this machine or that machine? Should I choose it to do it in this region or that region? So integrating that kind of mode of thought into their development cycle or job initialization cycle, that is a little bit more challenging. And if we have time later on, I actually have a question for Loïc on that, but maybe let's give
I have one, I think, a very like a gossip question for Loïc here from the Suman was asking, do you have any planned cooperation with one of the cloud companies in order to combine your calculator on their ecosystem? That was one part of the question. The second part of the question was, do you have other stories of cloud companies that companies that were trying to object to you or trying to say your work isn't valid?
So for the first part of the question, well, not really, but because they don't need us. Like, you know, our calculator is not rocket science. You know, it's on GitHub, but also the formula I've shown you, it's basically it. So, you know, it's not like they need our tool to do the calculation. They have all the data themselves. They can do the math. So it's just you know, it's easy. If they wanted to do it, they could do it in basically the blink of an eye. It would take very little resources, and you know, they would put like a developer on it for a little bit just to decide how to present it. But they could include that with like no problem at all. It's just a will to do so. And for the, so yeah, I mean, yeah, companies could do it. Well, cloud providers could do it easily. They just don't really want to for now. Well, they want to as long as it's a good marketing. And I would love to be proven wrong and to be proven that actually, you know, there's some genuine concern behind it. And if that changes in coming years, I'll be really happy to include that as a very positive in my slides. I'm looking forward to it. And the second part, what was the second part again? I lost it.
If there was another story besides Google of a company that was objecting, you or trying to say your work is not valid.
Not really. Not really. To be fair, because we're working on like computation in any kind of shape or form, you know, it's mostly academia, so people don't really look at it. I've had, you know, in academia, I've had people telling me, oh, you know, but we trying to save the world, or we're trying to like cure disease, so we shouldn't look at it. To what I respond, yeah, but 4.2 million deaths per air pollution is probably not no good, you know, outcome for work. So no, not really other companies. It's mostly like just saying, oh, you know, AI is not that bad. That's been the main pushback, and that's been mainly from Google, because, you know, they have like DeepMind and a lot of AI-centered research. Other than that, it's no one wants to be the face saying, oh, climate change is not a thing. What lacks is like the motivation to actually do something about it.
You can go, Chaim.
So my question is this. So I was wondering, as you were speaking, great talk, by the way, Lloyd, thank you. What do you think of the idea? The idea I had is, so I love the tool. You know, Ohad introduced me to this tool a couple of weeks ago, and I have been using it quite a bit since, and I really like it. I actually play around with it and share some of the results with my colleagues. But you know, I'm an engineer, so I'm very results oriented, and you know, the problem I'm trying to solve is, how do I get my colleagues to, you know, take these things into consideration and make better decisions that are more climate friendly. You know, which is behind, you know, I made the proposal that I made, where it really forces the user to make decisions, and, you know, puts up in front of their face decision between the dirty instances and clean instances. What I was wondering is whether you thought about a way of perhaps integrating the green algorithms tool into this decision-making process, into the AI job initialization flow. And to get it a little bit more into details, what I mean by that is taking, perhaps in the case of AWS, taking the Python photo API, which basically exposes all the possibilities to initialize and start up any of the AWS services, and wrapping that with a GUI that presents the user with a carbon footprint of the different options.
Yeah, no, that's I mean, that's a very good point, and I went fairly quickly, but that was the point of like removing friction further at the end of my talk, like what we still need to do. And you're completely right. The calculator is fun, and you know, if you're willing to put the effort in and plug in your numbers, you'll get the value and you'll get some details. The only thing you don't have with that is well, you still need to do the work, you know, and if you run like 100 pipelines a day, you can't plug everything into the calculator. It just doesn't really work. I guess you could use it with like the URL system, so you could use it as an API a little bit, but it's not really made for that. It's not designed for it at all. So it's a tough question. I'd say the first thing is we need to make it easier. So one thing would be for people working on cloud computing to, you know, just have this information. The idea to wrap it in AWS is a great idea. The thing is now, initially I wanted a calculator because I wanted something that would work for everyone. I didn't want people to have to install anything. You know, I was just, you go online, you know, it won't break anything in your pipeline. It's fine, you just do it. But now we need to go back to that a little bit and say, okay, the easy option is out there. Now people who want something more automated, something that will tell them beforehand. And it's just, I mean, it's just time and resources really, because, you know, for each platform, you need to do like a dedicated system. So a wrapper for AWS. We've been working on, that's something that I will put in it's already on GitHub. It's all like green algorithm for HPC. But I think for now it's still on my GitHub. I'll migrate it to the green algorithm GitHub soon.
So just so that you're not surprised, I just took a couple of minutes to submit it as a feature request on your GitHub.
Go. Yeah, no, go for it. No, I mean, feature requests are great. Yeah, there's potential. So we basically was saying it's something that's integrated in Slurm. So I don't know if you're familiar with that. Slurm is like a workload manager on a lot of like HPC facilities. And so, yeah, that's basically something that's integrated in it. And we've worked with it with some colleagues here, and people find it really good because they don't have to plug in anything anymore. They click on a button, well, they like send a command line, and it tells them the carbon footprint for the past month. But again, it's something that needed to be developed, especially for just this one platform. So now we're at a point where, yeah, each platform could gain a lot from having carbon footprint embedded into it. It's just it will come, hopefully. It's just effort and time.
Great. So after this part, I think we're finally made it through. At least it was my first webinar, so thank you everyone for participating and joining and allowing this to happen. And of course, SQream, who made it all possible, of joining all of my passions at the same, hour, 90 minutes. Not 90 minutes, how much are we? 75 minutes. Thank you for everyone who joined. I hope you took some practical tools out of there. And of course, each and every one of us gave you all the options to reach out and contact us and keep the questions and discussions wherever you can go. Hopefully you will convey the message wherever you're sitting and wherever your companies are, and to your colleagues like Chaim is doing, Loïc is doing. And thank you all for joining. Noah, up to you.
So thank you, Ohad, and thank you, Loïc, again for participating, and for all of those who attended our webinar, Understanding and Reducing Carbon Footprint. Don't forget that you can follow us on our social media, if it's LinkedIn, Twitter, and Facebook, and also our Life at SQream on TikTok, which is quite brand new. And also you can find us, you can find our website and look there. And if you want to contact us, we're here at all platforms. And thank you again, and have a nice day. Thank you.
Thank you. Bye.
Bye, everybody.